Well, just tell me, okay? I think I will be. Okay, so in this session, okay, I will introduce you to the one of the solution developed over Hbase, that is called Hindex, secondary index in Hbase. Okay, so which helps in faster Hbase queries. Okay. Okay, first, who am I? Okay, I am Bhupendra, and I am a senior system architect in Huwaei, and I am the lead for the Hadoop Hbase component. And also I am a Hbase contributor, and I am here for more than 10 years of experience in this domain. Okay. So this is the agenda. We'll talk about first of all Hbase, because I am not sure how many of you are aware of Hbase. Oh good, that's good. So we'll have a quick recap of the Hbase fundamentals. Then I will introduce you to the Hindex solution, then its usage and the test results. Fine. So as in the previous presentation, Madhuka talked about the smart sources. So even the Spark, SQL layer and all, pushing down a lot of things to the underlying data sources. Even the Hbase was one of them. So when it comes to the queries and getting the column values and even filtering, so even Hbase has to be the smart, otherwise your overall solution will not be working when you are integrating Spark SQL or the Hbase, right? So this solution is one of the things which will help in that. Okay, so let's start. Apache Hbase, it's an open source distributed non-relational database, belongs to NoSQL family, columnar storage database, so you must be aware of. It is based on the Google's Big Table paper, which was published sometimes in 2006. So design is based on the Big Table paper. Okay. And it has the distributed capabilities, that is because underlying storage is the HDFS file system, so automatically the distribution and replication part automatically comes. Then Hbase allows the random read and write access over the HDFS. So the goal, actually Apache Hbase, the main goal of this project was to support billions of rows and many columns, millions of columns. So that's where it performs very, very better than other databases. Right. So we'll just see some of the characteristics of the Hbase. Okay. So from the first slide we take it as a key value pair. So it's like a map. Key value, fine. Then the data is sorted. Data is sorted based on the key. Okay, so it has become a sorted key map, sorted map. Sparse. So the one of the main advantages here in Hbase, when you store the data, you no need to define the schema previously. I mean, the number of columns can be dynamic. Okay, so when you start putting the data into the Hbase, you no need to say how many columns you are going to have. As and when you load the data, the number of columns can increase up to the millions of columns. Okay, that's why one of the characteristics is sparse. Then it is multi-dimensional. Yeah, so because the cell value is not only represented just by a key, there are other attributes, other dimensions which are participating in when you store the data. When you represent a cell in a Hbase. Okay, so one is of course the key. So there is an example. One is of course the key. Then there comes to the column family, column qualifier, timestamp, and finally the value. So I'll just give you an example. Here you see it's like an employee table. So there is employee ID, let's say, is the key, and the title is the value. So let's say an employee is as a software engineer for some certain duration, and then he becomes the technical lead, like that. Okay, so it's like the same employee ID, but you want to have two values. Okay, so that's where Hbase support the versioning. It is represented here as a timestamp. So if you see the title, there are two timestamps, T1 and T2, which one will represent as a software engineer, other one is representing as a senior software engineer. So it's like our sorted map. It's a map of map. Okay, key then versus column family and other attributes, and the value is actually the list of values, we can say. It's based on the version. Right, so our map, sorted map, map of map, and value is list of value based on the versions. Fine. Next. Distributed, already talked, it uses the HDFS, which has the replication and all built-in features. So finally, the Hbase table also going to store all the data into HDFS. So that's where the replication and distributed nature comes into the picture. Next. Okay, auto sharded. Okay, so this is one of the characteristics of the Hbase. Okay, what I mean by this is, so whenever the data grows, when you are inserting billions of records in your table, So what happens is this table will become big, okay, and maybe it's like not one server can handle this much of data, right? So the auto sorting feature will split the table into multiple subtables or small tables, which is called as a region in Hbase. Okay, so now our map, which I was talking, sorted map, it's like a many maps. Many sorted maps are participating in one table, right? Fine. So here in this example, if you see, it's like two regions are available, sorted data, and the region information is maintained in some meta tables like that, which each region is representing from which key to which key, what is the value stored. Okay, so we have now many sorted maps. Fine. Okay, next. Okay, so finally, these many sorted maps actually. The final data store is represented and as a Hfile. When you store the data into HDFS, it is called as a Hfile. Okay, so the data is stored per column family. So our map is based on the per column family. Fine. Next. Yeah. So we now understand like what is the Hbase is already overall doing, right? So we'll just go to the high level introduction about the Hbase architecture. So there are three main components. One is Hmaster, region server, and there is of course zookeeper for coordination purpose. Hmaster role is, okay, so there will be in a typical deployment, there will be one Hmaster followed by backup Hmaster, and then there will be many region servers. Fine. Hmaster role is mostly to coordinate between the region servers, okay, and do the administrative operation. The actual read-write operation will be done by the region servers. Okay, so whenever any request is coming for writing the data, reading the data, it will be handled by specific region server. Okay, so as I mentioned in the earlier slides, our big table was actually divided into many small regions, right? So each region will be handled by one of the region server. Okay, so one region server internally will have many regions. Okay, and then okay, we'll talk about fine. So if you see the internal structure, so each region is backing up with the Hfile, which is internally many HDFS blocks, H blocks. Okay, and then it has also a mem store. So whenever you put any data, first it goes to the memory, then it will be persisted to the Hfile. Fine. So this is the overall region server structure, wherein region server is having many regions, hosting many regions. Fine. Next. Okay, so this is one of the entity in Hbase architecture which is called as a coprocessors. Okay, because the second index design is based on the coprocessor, so I will just introduce you to the coprocessor concept. So there are two types of coprocessor available: observer kind of thing and endpoints kind of thing. Okay, so observer you can think of as a triggers in the databases. Okay, so it's like any read-write operation you want to do, and so it's like a pre and post action, the trigger will be available to you. So it's like a custom hooks available in the Hbase architecture. Okay, so if you see in the picture, so with the observer kind of coprocessors, whenever any data read or write operation happens, client can write their own logic before executing the action and after executing the action. Fine. And there are other coprocessor which is called endpoint, like on some procedure, so which you can execute anytime. But the main thing is like, for an example, aggregation. So if you got a lot of data, like this query got a lot of data, and after that you want to do aggregation, then this kind of coprocessor hook can be implemented. Fine. Next. Filters. I think no need. I mean, whenever a client sends any request, scan request that is called, it can also put a filter condition. So internally based on that filter criteria, the overall output will be fetching. Next. Okay, so we'll just take an example to understand the concept. So Hbase query. So Hbase by design, if you see, everything is indexed by key, we can say. Everything, it's a key value, so everything if you want to fetch based on the key, it will be very fast. So in this example, you see a key equal to, okay, it's not it's a NoSQL database. Just to give an example, we have put a SQL query. If key is 141 and it wants to get the data, so it will directly jump to that particular row and get you the data, whatever you want. Fine, no problem. Next. Okay, let's assume a scenario wherein the query is by column value, okay, not by the key. So you want to get the mobile 123, name of the person, fine. So now what Hbase will do? Nothing. Actually, Hbase doesn't provide any functionality by as such, okay, to do this. What it will do is internally the query will go to all the region server, it will scan all your data, will compare the criteria and will fetch you the required number of rows. Fine, no problems. Query will execute fine. What is the problem? It will be full table scan, of course. Next. Assume billions of records. We all know on the big data, such queries will destroy your overall performance of your cluster, right? So such things are not recommended. Side effects, okay, the client, it will be just waiting and timeout. There is no end actually. So it's a bit not useful, right? So that's where our Hindex solution will come into the picture. Okay, so overall this much was already available in the Hbase, already available. Now I'll talk about the solutions which will solve these problems. Fine. Okay, so Hindex, as I mentioned, coprocessor is the hook where we can plug in your custom implementation, right? So second index solution or Hindex solution is based on the coprocessor. Okay, it's complete server-side implementation. What happens in this solution is, so whenever a master table is created, there will be one more table, index table, which will also be get created. Okay, indexing concept we are all aware of. It's the same concept. Okay, then the indexing will be done region wise. So our big table, many small region. So even index table, index will be created based on some region. And the main thing is this region, master table region and index table region will be co-located. It will be handled by same region server. Why so? So that whenever a request comes, it need not do a network call. It will be like a local call, right? So that's the advantage. That otherwise it will network overhead will come into the picture. Then fine. Go to the next slide. Yeah. So this is the overall design of Hindex, the architecture. So if you see here, in the Hmaster side there is a coprocessor host. And then in region server side also there is a coprocessor hook. We are calling this as a indexing coprocessor. So whenever a table is created, request goes to the master, it will use the indexing coprocessor to create the indexing table. Whenever a read-write request comes to the region server, it will make use of indexing coprocessor and first query the index table, then query the master table, right? Fine. And then there are balancer to co-locate. As I told, co-location will help. So there are balancer to co-locate the master region table and index region table. This example, okay, I'll just explain. So assume this is our master table row key and these are the values for column 1, column family 1, column 1. Okay, this is the index table. Okay, this first one is a region start key. So from where this region start, this for internal process, then followed by the actual value. Okay, and then followed by the actual row key. Okay, so if you see A belongs to 001, this is the row key. Next A belongs to 005, this is the row key, and it's sorted. That is the Hbase nature, sorted map, right? Okay, next. Fine. Now, yeah, we'll see the same example again. Next. Fine. So it's clear now. Directly it will go to the index table first, get where is mobile 123 value, and then what is the row key. Directly get the data for that. Fine. Yeah.
Is the index table is as big as unique values?
Yeah, right. Yeah, right. Because in index table, go to the previous slide. In index table, this is the row key. So Hbase by design, if you query anything based on the key, it will be very fast, right? Because it is indexed based on the key. It's right. Fine. It is index maintained per region, not globally. That I already explained. Go to the next slide. Fine. This is region co-location which I talked. So they assume this is the actual table which is having region 1, region 2, starting from A to B is one group, B to C another group. This is the index table. Same way A to B, B to C, it will be co-located in same region server. Okay. So this R1 and this R1 will belong to the same region server. Okay. Next, put operation. So whenever you are putting any data, it will go to the it will also create a similar corresponding entry into the index table. So that's the takeaway. Next. Scan, yeah, fine. As I explained, when a client sends a scan query, it will first go to the index table, it will open a scanner for index table internally, and then next. Whenever you do next, seek any operation, similar operation internally will be happening on the index table, get the corresponding row keys and get the data. So this is overall scan flow, if you see. Okay. So scan request comes, internally goes to the index table, get the data and do the actual seek and all in the master table. Fine. What is the advantage? If you don't have index table, it is going to load all your HDFS blocks, everything, it has to read the TBs of data, right? So now with this particular thing, it will directly jump to that particular row index and it will avoid many of the blocks loading into the memory. So overall,
again it has to read all the indexes from the table. What Madhu was saying is, suppose there is 1 billion unique elements,
right.
There will be 1 billion unique indexes.
Right. So yeah, I'll give you an example. So in our PS example where mobile is 1, 2, 3, okay. So in Hbase the data is sorted according to the key, okay. So now when the query comes 1, 2, 3, it will internally form a key like this is my region start X 1, 2, 3, and now there is a meta available like where this particular key is located, like which region server. Okay, so it did not do the full scan, it will directly go to that particular region server, get me the data for this particular key, right? Now, all these H files are sorted order and it has a meta, okay? So when it just see the meta, whether this particular key falls in these files or not. It doesn't fall, no need to load the complete file. Then like that it will skip. So index table read will be faster, right? Okay, usage, okay, maybe I'll skip because it's not very. Yeah, so similar examples for AND queries or queries like that it comes, how it internally will make a index, make a key for the index table. That is the main thing actually, how it makes the key for the index table, because after that just fetching the row from there. Anyway, we can skip this part. Next. Okay, yeah. Region split, same nature. So whenever when we initially talked about like it's our big table and when the data grows it will split into many small regions. So now whenever the auto split happens, same thing will be taken care in the index table. Okay. So whenever master parent table is splitting, index table also will split. So all these are implemented using the custom hooks provided in the Hbase architecture. Okay. Next, yeah, usage. Okay, so this particular implementation is also available. The source code is also available in the GitHub. You can check github.com Huwaei Hadoop H-index. You can Google or this link you go. The complete source code and its complete detailed design and usage is already explained there. And there is already, go to the next, Jira going on to integrate this solution with the Hbase. In open source it's already going on, right? Fine, this is all configuration and all. Maybe we can refer to that link. No need to go through here. Next. Test result, yeah. So we'll just see some of the test results. After this, what is the benefit we get, right? Yeah, put performance, okay. So see, as I told, whenever we are putting the normal data, we are also putting the data in the index table. So obviously there is some overhead, right? So is that overhead really big or not? We'll see. So if you see this comparison chart, so without index, the data size, if you see 100 GB of data, if it is taking 1263, with single column index, it will take 1593. So it's 300 seconds more. So that much overhead will be there. So this indexing, and I mean, if you can even create 3 columns index, multiple index, composite index, all those facilities are available. So this index, when you specify, it should be based on the scenarios which customer is looking into, right? Otherwise it will become an overhead for the storage and other part. Next. But if you see the scan performance, the real benefit, okay? So without index, a query, you see this numbers are based on the 5 region server, wherein the tables was having internally 100 small regions, okay? Small 100 regions. And then the overall size was 50 GB data. If you see, to fetch 9,600 18 records over 100 million rows. Without index it will take 587 seconds, but with index it will take only 55 seconds. So you can see it's almost 10x, right? And then you can even see if the data fetch result is more, it's 1,77,000 like that. So here also the same difference comes in the picture. Fine? Next. Okay, this with the AND filter and OR filter, if you want to experiment, but no need, fine. Skip. Yeah, so this is, I will just summarize this overall solution. So by design, it will support single column index, multiple column index, and even composite index. Okay, so if you have a column C1 and C2, if you want to create an index, maybe you can create a composite index, because your query will always come C1 equal to something and C2 equal to something. So no need to create two separate indexes. You can create a composite index. So that is one feature. Then support equal and range conditions scan using index, that is fine. Supports dynamic add drop index. Yeah, so this index can be created anytime. So if you already have some Hbase data store already there, and if you want to create an index now, so that facility will be available with this solution. Then support hints to skip index. Yeah, that's no problem. Intelligent filter evaluation. So when the query comes for the scan, so it has internal logic to skip even in the index table. So that's by design. Then application usage. So from client side there is no change required as such. Okay, so the client, it used to do normal scan, it's the same way. Internally server will decide if the index table is present, it will automatically create the scanner and process the query. Yeah, fine. Yeah, as I told, Hbase community, this discussion is already going on to integrate this solution. Then there are some tools which we need to enhance. Then pluggable scan evaluations. Yeah, so there is some core logic change in Hbase. We want to make it pluggable so that anyone can put their own evaluation logic like that. So this is the roadmap. Next. Okay. Yeah, any questions? Yeah.
When you are querying, do we have to give any hint that we will this index or anything, or it will automatically?
It will automatically, because as I told you, right, the master table and the index table is co-located in the same region, okay, and there is a meta available. So what will happen is it will query based on, let's say value is 1, 2, 3, so it will automatically form the key. So what key I need to fetch in the index table, okay. What it doesn't know in the key, the final row key of the master table, right. So 1, 2, 3, so it will, the query will be in the index table will be starts with 1, 2, 3. Get me all the rows which starts with 1, 2, 3. Okay, and data is in the sorted order, so it will hit only one particular Hfile. Okay, assume. So that way it will get the master table row keys first. So user client side no need to specify any index keys and all. It will automatically be done in the server side. Yeah.
How this expression will decide when that key column has to be indexed?
Yeah, that when to specify, right? Yeah, when to specify means when you create a table, you can specify on what all columns you want to create an index, or if the table is already created, later you can modify the table schema to create the index.
That means in client side we need to change.
Client side, yeah. So client side, when you create a table, you need to give attributes like on which columns you want to create an index. That's the client side attribute. That's it, right? Yeah. Any other questions? Fine. Okay. Thank you.